Hello, I'm JW, and once again with this CNC machine, and this time we're having a look at the limit switches and how those are wired in. And the limit switches are essentially what the name describes. It's a switch which goes at the limits of travel for the three axes. So it's going to be 6 switches for this machine, 2 for each axis, and that's 1 at each end. And the purpose of these is to make sure the machine doesn't actually go beyond the mechanical travel, because without any switch there, then the machine's got no way of knowing how far it's actually permitted to go. So if you got to the end, the motors would just keep powering on and ramming through the end stops and possibly causing damage and destruction to the machine and anything else in the vicinity. And we're also going to be using 3 of those same switches as the home switches. And again, this is how the machine knows where the sort of origin or the 0 point is, because if you just turn the machine on, it's got no way of knowing where the actual axis is located. And those can be therefore used so it can establish a sort of 0 reference for the X, Y and Z axes. Now, in terms of how they actually are wired, it's very straightforward. Basically, we've got the 2 wires from the controller, which in this case are a 24 volt actual contact supply, and we've got our switches which are in the normally closed position, and we've actually got 6 of these. And normally closed means that they're closed until the button is pressed, in which case then the contacts will open. And they could be wired in the other direction, but it's generally better to do them as normally closed, because that way if there's some kind of break in the cabling, it also shows up as a fault. Whereas if they were normally open and you were relying on one of them to close, then if the cable got broken or damaged, then essentially none of the switches work and you wouldn't know about it until the machine smashes past the end of the mechanical travel. So 6 switches, and the wiring is simply just taking 1 wire to the first switch, linking on to the next one, and the next one, and the next, and the next, and of course the next, and then finally it goes back to the controller. So the deal is then that it's essentially one big loop of wire, and then if any one of the switches is pressed, then basically that will break the circuit, say there, and then of course it will detect that the thing is open and trigger an alarm or whatever on the computer. So here's one of the switches, so they're all the same. This happens to be on the Y axis, and it's at the furthest end of the travel. This is actually the motor just underneath here. And for this one I've just mounted it on this plate here, which is just a convenient location. I've got a few blocks of plastic underneath just to raise the switch up to a suitable height. Cable comes in the back, and the cable we're using, which is this one here, is the same CY cable that we've used for pretty much everything else. Now for these we only need 2 cores, or 2 individual wires. Of course this has more than 2 in, but because we've got a whole roll of this we might as well use it. And it also happens to fit pretty well in the rubber piece here on the back of the switch. So the deal is that when the actual thing moves along here, when it gets to this end, which of course is the mechanical limit, then it will actually press this, and that will just open the contacts, and then the controller will know that it's got to the end of the travel. Now these can actually be wired up either way. I'm not going to do any particular detail on these because it just happens that Big Clive did a review on these various switches just the other day, so there's a link to that video in the usual places. But essentially it's a pair of contacts inside, so the wire comes in through the contact and goes back out. When you press it, then that contact is opened, so of course then it detects that there's a break in the circuit. So that's the Y-axis switch there that we just saw, and so the cable just comes out and it actually goes into this small box here, which is where various cables connect together. Now this pair, which you've seen in previous episodes, that's for the external emergency stop, which we'll do later. And then here is basically the interconnection for the various limit switches. So basically it's a wire from the main controller comes in, goes into one, and then we've got a wire going out to, say, one of the switches, comes back to the next terminal, goes out to the next switch, comes back, goes, and so on. So basically got that continuous loop going all the way round. Now this box only has some of the connections in, because basically we've got here the wires coming in from the controller, one going to that limit switch we just saw, one for the other end of this axis, and then the other 2 pair, or the 2 wires there, actually go up onto the gantry, and they go into this box here. And then inside here we've got a very similar arrangement, so again we've just got each pair, so it goes in, comes back, goes in, and so on, and again continuing the loop there. And this is for the 4 switches on the actual gantry up here. So the x-axis here, it's just the vertical there, and this actually just moves across, just presses on the contact. and the other end is pretty much the same. You can just see that over there in the distance. The Z-axis, here's one of them, and then the other one is actually just around the corner over here. And the deal we got here is that this piece here moves vertically with the actual axis, whatever. So when it comes up, this plate here presses on the bottom of the switch there, and then when this moves down, we've got another plate at the top here, which basically comes down and presses onto that. Then the Y-axis, they've already seen that, that's just one over there. So as the carriage comes along, it will just press onto that. There's the carriage there. And then the other end of that is pretty much exactly the same. So again, there's the switch down there, and then that just presses onto the end of the actual carriage there as it moves along. Now I'll just show you the actual homing sequence, and the deal here is that the machine will basically move each of the axes in turn until it actually gets to the switch, either this one, the one down here, or the one up on the top here, and it will move it towards the switch. When the switch contacts, it will obviously detect this, and then it will actually move back off of the switch until it opens, and then it will repeat it for the other two axes. So that's how it basically knows where the sort of 0 point is, because otherwise it would have no way of knowing. I mean, obviously you could have turned the machine off and then moved this and turned it on again, and obviously it wouldn't have a clue what was what. So we'll just demonstrate that function. So now all of the three axes are in essentially the 0 position, and although they're actually still contacting the switches have actually opened, or the click has actually closed those contacts. So that's basically now the 0 position, and that will also reset the software so that it now knows that that is the furthest extent, or basically 0 in terms of the machine positioning. Here's what it looks like on the actual machine. So when first started, notice all of these are red here, which means it's not been properly set up or anything. So if we just enable that here, and basically what we do is click on the ref or home button, which will then move these to the limits and then just off of the switches, and then we'll see that all of these will then go green. So so now they're all green there, and also these will reset to 0 after it's done the movements. So that's using the three switches that then is basically the home switches, and if we have a look in the diagnostic screen here, these basically will light up as various things are turned on and off. So if I actually press one of the switches, you see that all 9 of those at the top will illuminate. So we've got X and Y and the home as well, so the two limits, which is the double plus and the double minus, and then the home as well, because in this case all the switches are wired into a single loop, so it doesn't matter which one that's pressed, the whole lot actually turn on and off at the same time. Now you could in theory wire these so that you had 9 separate inputs, so you would have to have lots of cabling coming back, so you'd have one for each of the limit switches, and then you could actually have 3 completely separate home switches as well with their own cabling coming back. There's no real point in doing that, but it's something you could do if you wanted, because although all these come on at the same time, the machine obviously knows, or the controller can know, which direction it's moving in, and therefore which limit switch is being tripped. And certainly for the home operation, if it's moving the X-axis and then it gets to a limit switch, well, it's fairly obvious that that's going to be the X home switch, and obviously for the Y and Z as well. And in terms of it, say it was actually cutting, if it comes across a limit switch, it doesn't really matter which one it is. The fact is it's obviously got somewhere it shouldn't be, so if obviously you're going to have to stop and fix something and deal with it manually. And also the fact that it's got to say one limit switch, and if you're actually cutting a part, it means that the part is probably ruined because it's obviously gone outside of the area you're supposed to be cutting, so some kind of problem has occurred. So although they're all on the same one, it doesn't actually matter. So you could wire them separately, but that just means a whole lot of extra cabling, extra switches required, and of course a whole lot of extra inputs used. Well, obviously it's completely pointless. Now in terms of the configuration for this, have a look in this piece in here. You see we have one here for homing and soft limits, and essentially what we've got down here are the various axes. Most of these we're not using because it's only a 3-axis machine, so basically it's the X, Y and Z that we're using here. This home direction is essentially the direction it goes in which to find the actual limit switch. So for the X and Y we've got it as negative, so it's basically moving back towards the 0. But for the Z axis we've actually got it as positive, because we're actually moving the thing up to the top of its travel. We don't want to be moving it down, because if you did and there was a tool in there, it could actually just graunch the tool into the bed and break it off, so that's obviously not a desirable feature. So for these two, X and Y are actually at the bottom corner of the machine, and the Z is actually at the highest position, so as you're actually cutting into something, you're actually basically minus and going to a negative in that regard. Most of the rest of these we're not currently using, although obviously we may well be setting those up later on. Now have a look in here for the actual motion controller configuration. And so this has a homing switch or homing tab as well. So essentially what we've got here then is the three motors we're using, which is 0, 1 and 2, which are the X, Y and Z. Again, the others we're not using. We are using motor 3, but it's basically slave to the Y-axis, so we don't have to put any separate settings in there, because essentially whatever happens to motor 1, motor 3 will do exactly the same. And the setup here we've got is, this is the input signal we've got, which in this case is X204, and these refer to the actual inputs labelled on that breakout board that we're using. Also we want it to be enabled, because otherwise it doesn't work. And then over here we've got the velocities, which are set as in the speed it will approach the actual switches, and then the speed that it will actually move away from the switch. Now by default these are actually set to 1. Unfortunately 1 is useless in the case of this machine, because this is set up as a metric machine. So in the case of this, 1 means 1 millimetre per minute. Now of course 1 millimetre per minute is so slow that you can't even see it moving, and it would take literally hours to even reach any kind of position. So clearly we've set some more appropriate things here at the moment, so currently 750 and 400. Set less for the Z-axis because obviously it only has to move a considerably shorter distance. And then the one here, which is set to 150, is basically once it's hit the switch, that's the speed it comes back off of it. And again, those are currently set a bit lower. Again, these can be adjusted for best performance, because you don't want it to take too long to get to the homing position, but on the other hand you don't want to be ramming into the switch at such speed that it actually causes things to be broken. Now the other configuration here, this is in the Mac configuration screen, and we've got here the input signals tab, and we'll see down here that X204, that's the one we're using for the home and limit switches, and we've actually turned this off here, so it's actually disabled there, and also number 5 disabled, that's actually the emergency stop signal, which we're using elsewhere as well. So it's disabled there, and then if we scroll down a long way, we can see in here we've got motor 0, 1 and 2 home set as that X204 again, and the device here is just basically the Ethernet smooth stepper. We've only got one. I mean, you could obviously set it to keyboard if you wanted a keyboard input, but obviously limit switches do not connect to the keyboard. So it's basically device, the input name, which is X204, and of course enable, because otherwise it doesn't work. And if we scroll down even further, we can see here we've got the positive limit, so again 0, 1 and 2, which is the X, Y and Z, and again it's the same device because we've only got one, and it's the same input again, so X204. And if we scroll down even further, then here we have the negative limit, so again 0, 1 and 2 for X, Y and Z, same device, and again the same input. So we're basically setting the whole lot to the same input there, so it's all X204. And that's why when we go back to this screen, and if we press the switch, you'll see that all 9 of those turn on and off whenever the switch is depressed. And it doesn't matter which switch, and I'm just pressing the Y-axis one there. Go to press the Z one, well, again it does precisely the same thing. And have a look down here on the history tab, which is way down at the bottom, and we can see in here that it will actually have a record of what's been tripped and whatever. Now the only disadvantage with having all these wired on the same thing is that when you actually press it, it will actually show as all of these tripping simultaneously, so X, Y and Z on the minus, X, Y and Z on the plus, and the X, Y and Z home as well. But again, this doesn't really matter. The only minor disadvantage is that if one of the switches breaks and say remains open, then it won't actually tell you on the screen which one is actually broken, so you're going to have to do a bit of dismantling and testing to find out which one is actually broken. But bearing in mind, switches breaking is a rare event, or certainly it should be, and if the switch is broken you're going to have to be doing some dismantling and things anyway, because you're going to have to take the switch out and replace it. So there's a minor disadvantage, but ultimately it doesn't actually make any difference in terms of operation. So we can just get rid of all of that. Now in terms of the actual limit function, so all we've seen there is the homing function. What will happen is that when it gets to the limit of its travel, then it should actually stop. So what we can do here, I'll set this to a moderate speed, so about 30%. Then I move the x-axis across. It should go across until it hits the limit switch, and then it should stop. So let's see if that's actually the case. Yeah, there we go. So it's now gone across the side, and it's now tripped, and essentially it's stopped moving. And we can hopefully just see at the bottom of the screen here that it now does say limit switch is tripped. Now it says Z there because, again, as we saw previously, now we have a look in here, basically it's just recorded that all of them have tripped. But the functionality is the same. When it gets to one of the limits, it's going to stop, and of course that's basically what we want. So we'll get rid of that. And you notice that it actually now says the distance it's travelled, which in this case is 634.11 millimetres. And of course it was 0 because we didn't move them. Now, if we just re-enable the machine here, you'll notice that these, which are the jog controls, don't actually work. And this is because it's actually on the limit. And so it says can't jog towards the limit and all that business, so it seems to be stuck. But how to undo this? There's a thing here which says limit override, so we can click on this, and then we can carefully jog away from the actual limit. Now bearing in mind when this is turned on, if you ram past the end stops and break things, well, that's going to happen. So although I know which way it's going to go here, the best thing to do here is to turn down the actual jog rate to a small level, say 1%, and then we can move slowly away from the limit switch, carefully looking at the machine to make sure it's going in the direction we want. Now in this case it's negative, so we'll just move slowly there. The switch is clicked, so now we can turn that back on, and now we're back to basically normal operation where we can move along in whichever direction we want. And it was the same on the Y there, so again that's now gone to the limit for that one. So again it's the same thing, limit override, move it away from the switch and switch off. And again if we go for the Z, this is going all the way down, which gets about 120. And again that's now the limit of the Z, so 118, well, near enough. And again it's the same deal there, so if it gets there we can then move that away from that. So that's the limit and home switches, in this case all being used as the same function. And so you can do them individually if you want to, but there's not really a great deal of point. It just means a load of extra cabling and even more switches required. If for some reason you wanted the limit and home locations to be different, then of course you would need separate switches, but again there's not really a huge amount of point, as obviously the machine is the size it is. There's not really much point in using less than the area that you've got. And of course those are only the mechanical limits. In terms of actually positioning say a part on there and actually cutting from a corner, then that's a separate setup, that's all done in the software. So although the 0 for this one is at a particular point right in the corner, you could obviously mount a piece of material in the middle and then just call the edge of that particular piece of material 0, and then it will obviously cut from that point. And again that's just a software setting anyhow. But in terms of the installation of those, then that's pretty much it. Now you could of course run these machines without any limit switches. I'm sure plenty of people actually do this, but the problem with that is you've got really no safety involved, because in theory the machine ought to stay within the bounds that you've set, and you can set on the machine what's called soft limit, so that you can basically do the same thing without any actual switches. But unfortunately that relies on the machine actually working correctly all the time, and if something got say jammed or the motor sort of missed some steps or something, then the controller and the machinery is going to be out of sync, and any soft limits are not going to work. And there's also that issue of it slamming into the end stops and causing damage. Now this machine is fairly powerful, so this slamming into the end and roaring off the stop is definitely not desirable. Of course lower power machine might not be such a problem, but in any case definitely a good idea to fit these things. And so these switches came from China, they're only a couple of pounds each, so really no cost involved there. So that's it for this time. And until next time, thanks for watching.